Okay, today we're going to be looking at central angles, inscribed angles, and their arcs. So to start off, we got some vocab here. So an angle with a vertex in the center of the circle is something that's called a central angle. So you'll notice the center of this circle is N. So since the vertex of those angles are in the center, that's called a central angle. Its sides contain two radii. So the radius of the circle, so 2 of the radius. And the sum of the measures of the central angles of the circle, so if we add all the central angles of a circle, we should always get 360 degrees in a circle. So you'll notice here when they say the measure of angle RMS, we're talking about that one. And then SMT, we're talking about this one. And TMV, we're talking about this one. And last but not least, VMR, we're talking about this last one. When we add all those together, we should get 360 degrees. And we're saying like, hey, if we knew that, like, let's say RMS is, 120, then that arc RS is also 120. But we'll kind of practice that in a minute here. Okay. When we talk about arcs, we're talking about, there's kind of two ways you can look at it. A minor arc is the shortest arc connecting two endpoints on a circle. So the minor arc, the measure of the arc is less than 180, so it's less than half the circle degrees, and it's equal in measure of its related central angle. So some examples of minor arcs here is like R to S. So the arc is the part of the circle. And usually have like a little line on top that represents an arc. Even like V and T, V to T, see how it just connects straight there, is going to be a minor arc. Or like ST, etc., RV, etc. Okay. A major arc, however, is the longest arc connecting two endpoints. So rather than it being R to S, it would go like R to T to S. They usually put like a third letter in there to help you see that you're going the long way around the circle. So like RTS would help you see that. Or maybe I would do VST. So rather than just V to T, right? If I did something like VST, I'd have to connect V to S to T. You see that's a major arc. We're going more than half the circle. Okay. Or even you could do, let's say, we already did that one. We could do S to V to T, which is actually the same as that other one we just did. It's going the opposite way. The measure of a minor arc is greater than 180 degrees, and the way you can find that is if you know the minor arc. So like if we knew VT, if this was like 60, then 360 minus 60 would give us that other one. Okay, semicircle is an arc with the endpoints that are on the diameter. So notice here, diameter of the circle. So our arc here could be like VS. And it's always going to measure 180 degrees, so half a circle. Last but not least, an inscribed angle is an angle whose vertex is on the circle. So like B is the vertex, it's the like point of the angle, and whose sides contain chords of the circle. So chords, for example, are like this line AB or this line BC, where they cross through the circle, but they don't necessarily go through the center. The measure of the inscribed angle is half the measure of the arc it intercepts. So our inscribed angle here would be angle B. And for example, if we knew that this arc, let's say, was like 70 degrees, then we know that this angle B is half of that, so 35. Okay, so we're going to go ahead and now practice. Find the indicated angle measure. So in this first one, we're finding this angle right here. So notice that is a central angle. It connects to the middle of the circle. and it relates to this arc, which is 40 degrees, so it is the same. So it is also 40 degrees. Okay, this time it tells us to solve for x. So you'll notice 78x plus 1 represents this angle right here. And it relates to this arc, which is 157 degrees. So let's write an equation. We know that the central angle is equal to that. So we'd have 78x plus 1 equals 157. Subtract 1 from both sides, you get 78x equals 156. Divide both sides by 78, you get that x equals 2. Okay, next one. This next one is an inscribed angle. Notice how it touches the edge of the circle. So remember the inscribed angle? Inscribed angle, maybe I'll just put it over here, sorry, actually, is half the arc. So notice here the arc is 114 degrees, so to find that question mark, we'll do 114 degrees divided by 2. As you do that, you end up with 57 degrees is that indicated angle. This is 57. Okay, this next one's a little trickier because we're looking for this question mark over here, but notice the arc they give us corresponds with angle E. So let's start there. So if we look at angle E, if we do 66 divided by 2, we know angle E is 33 degrees. So you could do, I guess there's two ways to approach this. I'll show you one way and I'll tell you another way. Actually, I'm going to just backtrack. I think there's actually an easier way to do this. So let's go back a minute. Okay, so this arc here with 66 does correspond to E, which we said was 33 degrees. But notice how that doesn't help us find the angle we're looking for. The angle we're looking for corresponds with arc E to F. But notice how we have a straight line here? So it means if I go from all the way from E to G, we get 180 degrees. So it's a half circle. So to find arc EF, I could simply take 180 and subtract 66. So I end up with 114 degrees. So this arc over here is also 114 degrees. To find this central angle, I'm going to take 114 degrees. Okay, so to find this question mark, I'm going to take my 114 degrees, and I'm going to divide by 2. So we end up with 57 again. Okay, let's look at the next one. Find the indicated angle measure. So this time we're finding the angle measure of the arc N to L. So we got to figure out a couple different things. Notice that's not a half circle, right? So we've got arc K to M is 76. And while I don't have the current measure of K to L, I could figure that out because notice we've got an inscribed angle here that's 66 degrees. So this time it's the opposite. If that is this inscribed angle, we're going to do 66 times 2, and that arc is 132. Now to find the angle we're actually looking for, we know an entire circle is 360, so we're going to subtract the 132 and the 76, such that we get arc ML is equal to 152 degrees. Okay, this time they tell us to find MCH. So you'll notice that it kind of has two parts. We've got the 80 degrees right there, and we also got to figure out this other angle. But since that's a central angle, it matches the outside, which is 47. So the measure of MCH is simply 80 plus 47, so we get 127 degrees. Okay, keep going on. This time we're finding X. So notice it's kind of referring to this angle, or it goes along with this arc. So we know all the rest of the arcs, right? We got 45, 110, 120, 40. So to find this missing one, we could subtract all the rest of these from 360, which is the total, and of all the arcs or central angles in a triangle, in a circle, sorry. So we get that this angle is 45. If this angle is also 45, just like the one next to it, we can set 6x minus 9 equal to 45. Add 9. 6x equals 54. Divide by 6. X equals 9. Okay. Ooh, this next one's a little bit trickier because we got to kind of look to see what's going on. So this first one's referring to angle D, which corresponds with this arc CB. The next one corresponds with angle L, which also corresponds to the same arc. Let's say that arc, for example, was 100. If that's 100, that means both these angles have to be 50. So with that in mind, even though we don't know what this arc is, right, it's still a mystery to us, these two angles, because they correspond to the same arc, the inscribed angles, even though they come to different spots in the circles, have to be equal. So we're going to set these two equal to each other. So I'm going to get my x's on the same side, and then I'm going to subtract 2, so x equals 14. Okay, last but not least, 2 more examples here. So this time we want to find arc M to V. The only issue is they didn't actually give us any angle measures here, right? But you'll notice that we've got a straight line through the center, so that's a diameter. It means that both of these together have to be 180 degrees, right? So the central angles and the arc angles will have to be the same. So when I add both of these together, I should get that 180 degrees. So we have 29x plus 6 equals 180. Subtract 6 from both sides. 29x equals 174. Divide both sides by 29. And x equals 6. And you're probably feeling pretty good about things, but since it asked for the measure of the arc M to Z to V, we're going to do 19 times 6 minus 4. When we do that, we get a total of 110 degrees is that arc length. Okay, one last one. Okay, they first ask you for R to S to T. Okay, so we kind of want to find out, first of all, maybe what RT is. So arc RT, notice I've got the other 3 arcs in the circle, so we know that they have to all add up to 360. So I'm going to take those away from 360 and see what we get for that arc length. So as I subtract 360 minus 64, minus 75, minus 139, I end up with 82. So it means that RT is 82 degrees, which means this angle at S is half of that. So, sorry about that, 82 divided by 2, because it's half of it, is 41 degrees. Okay, now let's look at the next one. R to U to T, that's kind of similar to that other one. Notice it refers to the same arc. So it is also, since it's an inscribed angle, is also 41 degrees. Okay, hopefully that's enough practice. Kind of gets you experimenting with those ideas, but some common things, first of all, central angles are the same as their arc, whereas inscribed angles, the ones that touch the edge of the circle, are half. And the other things you kind of want to look for is adding all the angles in a triangle, and like the central angles or all the arcs up to 360, or looking for that diameter, right, that half circle, which will be 180. Good luck with your assignment.